Okay, so I know you can't see the whole screen, but that's kind of by design. What you're looking at here is a VNC connection to my Raspberry Pi 4. So I've got the screen limited down to the app itself so I can show you stuff in the same window. So here's my home folder. I have view uh, the hidden files hidden. I don't want to mess with those right now. So when you go to here, you're going to end up after the install with a scouting folder. And inside the scouting folder, you have the two applications, and then you also have an icon. Well, PNG, sorry. All right, so if we launch this, and I'm deliberately doing it from source, or not source, but the actual files themselves, it'll ask if you want to execute, and of course you say yes, and it's going to boot up just fine. Now, this is the current version of the software running on Raspberry Pi. And if you notice the speed of how fast that booted, even though it's being booted and transmitted via VNC to my Windows machine to render the image for me to copy and make this video, it's pretty darn fast. It basically boots up as fast on a Raspberry Pi 4 with only 4 gig of memory as it does on a Windows machine. So there's going to be a number of differences that you're going to see. I did initially use a control that made pretty buttons, the blue buttons, the green buttons, the red buttons, and that sort of thing. Outside, well, that's the grid doesn't count because there's no grids here. The grid control doesn't work in ARM technology. Raspberry Pi, many of you know that Windows is x86 or it's x64, but it's still the old IBM machine. So Raspberry Pis are completely different. They kind of think different as well, other than the fact that this is Linux. This is Raspbian running on Linux on the Raspberry Pi versus Windows on Windows. So everything about the two is different. This is ARM technology, which is the little single board computers that have come an awful long way in the last 10 years, 8 years since their invention. The original Raspberry Pi, then came 2 and then 3. 3 was quite the smash in the world because it really was a real full machine and it only cost $35. So the 4s are pretty hoss. The 5s are about 7 times stronger than the 4s, but they also require more power. So that's why my decision was to suggest using the 4s because they're still pretty powerful. But ARM technology is designed from the ground up to save power. Windows and Windows applications, their machine hardware is designed mostly for performance. And when you start talking gaming, your power consumption goes through the roof. That's why video cards require whole new power supplies and units. ARM technology, well, they can't, I won't say can't, they can play games and whatnot. This right here can play most of the games. It can play Diablo 3, it can do all kinds of stuff. But this machine, the Raspberry, will require far less power than any of its Windows counterparts. So the part of the goal in this project was to minimize the battery necessary for the scouting units to be able to run for 12 straight hours without needing a charge. And that's going to require some horsepower. I mean, we're going to be talking 400,000 milliamps or something to that tune. And if you read the document on building this, you'll see some of the thoughts I have on power. Until I actually build a Raspberry Pi scouting unit itself, which will be later this month, I won't be able to track the power usage. I'm kind of using a swag of the screen requiring as much power as the Raspberry. Since you're not playing videos, you're not playing games, the power consumption should be relatively low. I've compiled the scouting app on the ARM machine. And so it is native to Raspberry. So anyhow, let's go forward with this. It pretty much works the same. Some of these screens you are going to see differences. The color of these buttons are just back to standard buttons. And other than that, it works pretty much the same. This will be tapping. We're going to sit here. I mean, it still all works the same. It just is visually a little bit different. I made these image buttons so they stand out. This is still a function here and works like a champ. I've actually sent data from the Raspberry to my Windows machine. All the requirements for the TCP/IP is that both machines are on the same network, and that you send to the host IP at the port that he's actually opened up for this. So this was my original configuration for testing the application. And if you notice, there's a whole lot more layers of scoring that we have here. Controlled is the same. I came up with a bunch more checkboxes and whatnot. So I think we only had one here. But that's pretty much, this is the application actually physically running on Raspberry as seen through a VNC viewer. So that ought to kill this video.